Good morning. My name is Arva and I am from Computer Engineering Division C. The topic that I have chosen for my internal assessment is DBMS, NoSQL and Securing Data, the Relationship and the Recommendation. The selected paper was published in 2020 International Conference on Innovation and Intelligence for Informatics, Computing and Technologies. The authors of this paper are Omar Abba Hussain and Abdullah Alaquddumi. Introduction. In the past, people used to store information and data on paper, placed inside boxes with letters representing the record title initials. It was complicated to retrieve the records when requested. Besides that, such records could be tampered. When computers surfaced, data started to get stored on them. But retrieving the data was still a hassle. And with time, the DBMS, that is the Database Management System, emerged in the 1960s. Having such databases helped greatly store different types of data, indexing and retrieving data. But as the system holds so much information, it becomes a target by cybercriminals. Later, NoSQL emerged to take care of an enormous amount of data. But it also faced the same issue of being targeted by cybercriminals. This paper explains DBMS, NoSQL, and its relation to DBMS and goes through potential DBMS threats. The Database Management System (DBMS), which emerged in the 1960s, is a software that creates and manages databases. Such software gives concurrent end users the ability to perform multiple operations on any table in the database. For example, inserting new records, updating, reading, or deleting them. Later in the 1970s, the RDBMS, that is the Relational Database Management System, was introduced. It is an efficient system that can perform more mathematical and flexible operations. NoSQL, or not only SQL, is a type of DBMS that can accommodate a wide variety of different data types and models while holding different formats, such as key value, documents, columnar, and graphs. It is schemaless and more flexible to adapt to changes. NoSQL goal is to dominate and be the next after RDBMS in the database market. It is mainly used for database clustering for a large scale of web and cloud applications. So following are the key differences between RDBMS and NoSQL. RDBMS is a relational database while NoSQL is a distributed database. They do not have any relations between any of the databases. When RDBMS uses structured data to identify the primary key, there is a proper method in NoSQL to use unstructured data. RDBMS is scalable vertically and NoSQL is scalable horizontally. Hence, in RDBMS, servers have to be added and power has to be increased. Maintenance of RDBMS is expensive as manpower is needed to manage the servers added in the database. NoSQL is mostly automatic and does some repairs on its own. As stated earlier, RDBMS is expensive due to the servers and storage management. NoSQL databases are open source and cheap when compared with RDBMS. RDBMS has a fixed schema so that the data has to be inserted in a proper format. This helps to get the primary key and foreign key to align the data in the table. But in NoSQL, a schema is not needed and hence data can be inserted in any form. Threats to DBMS. DBMS contains plenty of data, of which main concern is the sensitive and private information. Such information is what makes DBMS targeted by cybercriminals. Now, they could infect the DBMS from inside an organization with malware that opens the backdoor to the criminal storage and transfers it. The data may be sold, or the data could be encrypted on the organization and demand a ransom to decrypt and release the data. Another way to perform an inside attack is by stealing the backup storage as they are left unattended. As for the outside attacks, cybercriminals would attempt to take advantage of any DBMS vulnerability that has no patch or yet to be patched. Cybercriminals' other way to perform an outside attack would be through SQL inject for the RDBMS and NoSQL inject for the NoSQL database. If it succeeds, such inject attack can gain complete access to the data which was stored. Now in the following slides, we will go through related work to understand the current DBMS market and its security threats, and then propose a solution. So Ibrahim and Mohammed conducted a survey to understand the security issues in big data and NoSQL. Massive amounts of data of different types through the network, security and privacy is of great concern. The authors present some security issues highlighting the privacy challenges in such infrastructures. Garcia explained how NoSQL is winning when it comes to big data, while RDBMS focuses more on operations. The authors focused on having an optimal security implementation in a NoSQL database where users have permissions and sensitive data that should be protected. Medeiros focused on proposing ways of prevention of injection attacks against the DBMS. The concept is done by embedding protection on the DBMS itself. It is done by securing the DBMS's operating system and applications and checking for any semantic mismatch of SQL queries. Wagner aimed towards a different approach to detect malicious behavior. This is done through the evaluation of live database integrity to identify and report any evidence of log tampering. By comparing the database logs against the physical storage of disk and RAM and find inconsistencies, tampering is detected. According to Ma, the paper illustrated the importance and policy of database security from different aspects: the security of DBMS, the security of the network, and cloud computing era database security. These should ensure the safety of data information in the DBMS. Now, Mohammed conducted a survey on the security system of DBMS and then proposed method. As the paper states that all information are essential elements and of high importance in DBMS, users trust their DBMS service providers in securing the DBMS to protect their data from any malicious behavior. The authors presented a few techniques that are applied to enhance the DB security level. Now, the proposed solution is to combine the NoSQL with RDBMS, where permissions are stored in NoSQL and RDBMS data. Such a combination should provide two defense lines so the stored data remains safe on the RDBMS. The logic and concept are to prevent DDoS attacks and/or NoSQL injects and loss of all stored data. Now, figure 1 shows a normal case scenario. A user enters his credentials, that is name and password, and goes to the online corporation server, OCS, which opens a connection with the NoSQL server to validate the credentials and respond with valid or invalid, followed by connection termination. OCS takes the response as follows. If invalid response, then shows the user an error message that the credentials are incorrect. And if valid response, it opens a connection with the RDBMS server. Now figure 2 shows internal attack behavior. A user computer got infected by a malicious code and the infection spread to other computers in the corporate network. The infected user computer starts attacking with credentials or flood the network bypassing firewalls. The OCS opens a connection to the NoSQL. The NoSQL starts receiving bulk credentials with the same pattern. The NoSQL server sends a flag response of attack where OCS first step is to initiate data lockdown on the RDBMS server to secure it, followed by network lockdown internally and externally to prevent the computer user's data leak. Now figure 3 shows external attack behavior. The attacker executes a malicious code that bypasses the firewalls and attempts an attack on the server by flooding it with credentials. Similarly to the internal attack, the OCS opens a connection to the NoSQL where the NoSQL detects the attack and responds with the attack flag. OCS initiates data lockdown on the RDBMS server to secure it, followed by network lockdown internally and externally to prevent the attack from outside and ensure the attacker did not attack internally. Whether the NoSQL data has been compromised or not, during the attack, the NoSQL data is purged and reinitiated using the data stored in the RDBMS and changing the hashes associated with each user, making the NoSQL data useless for the attacker to construct a rainbow table or finding the right hash and finding out the correct credentials. Now let's have a look at the limitations. Implementing and testing this framework requires 3 servers and complete control of the network connection between all servers. A NoSQL server that will hold the verification data, an RDBMS server that will hold the actual data, and the system that will react according to requests from the users and responses received from the servers. Conclusion. Cybercriminals will always keep exploiting vulnerabilities and attempt to steal data from organizations. Thus, one must make sure how sensitive the data is and where to store it, such that access is very limited to it. Also, users should make sure antivirus is installed on the devices in case of a breach. The devices would not be affected. This study can be expanded further by implementing the framework. Aside from that, the paper will go in depth explaining different connection types, hash algorithms, and logic of keeping data secure. This is the bibliography for the selected paper. Thank you.